Hello and welcome to Ambient Tutorials. In this video, I will talk about synchronization. Timecode is not synchronization. To explain the difference between the two, we can take a look at the following example. In this scenario, there is an audio recorder sending hardwired timecode to 3 cameras recording a concert. The timecode is perfectly constant, as all cameras receive hardwired timecode from the audio recorder. However, when the editor plays back the material after initial alignment and post, the material gradually loses sync and gets worse as playback continues. How can this be, as all units have a hardwired timecode connection? We have to look at the individual devices to understand the problem. Each device and its internal components operates at a unique speed determined by its internal processor clock. So within a camera, its internal processor clock determines the speed of the shutter, the video processing, and the A to D converter controlling its internal audio tracks. And each device's internal clock has a different level of accuracy. So even if you begin recording at precisely the same moment, the recordings captured at different clock speeds will gradually lose sync with each other beyond the first moment that they are played back in post. At this point, one might still ask, why doesn't the constant timecode prevent this problem? As we are using modern, file-based production audio and video recorders, the timecode is simply a documented stamp referencing the beginning and the end of the recording. As the timecode is controlled by the audio recorder's clock, the audio files and timecode are in perfect sync. But the cameras are all running at different speeds, so the captured material and the timecode are at different speeds. In other words, the position of the material does not match with the timecode. This is called drift. As the recording gets longer, the drift gets worse. But in situations with only short takes like most feature films, drift rarely presents a problem. When shooting events or documentary-style productions, it often produces headaches that can easily be avoided. SMPTE defines certain synchronization formats to deal with this issue to enable multiple devices to run at the same speed as a master clock source, so the slave devices run at precisely the same speed as the master clock. So let's take a look at different sync formats. The video sync format is called GenLock. Basically, it's an impulse generated per video line and is specified by video resolution and frame rate. These specifications include PAL, NTSC, HD 720 and 1080p, PSF, or interlaced. Anything beyond that is unspecified, such as 48 frames per second used in The Hobbit. In the audio world, the sync format is called word clock and is specified by sample rate. So how do we solve the sync issue in our example? The material will sync when we control the clock speeds of the individual devices. There are 2 ways we can accomplish this. With the central house clock and the OB van with the GenLock sync and word clock outputs hardwired to all devices. Or portable, high-accuracy clock units with GenLock sync output connected to each camera, with word clock available for the audio recorder depending on the accuracy of its internal clock. The hardwired system is inconvenient as it lacks mobility. The portable clock system, such as the Locket Sync, is far more flexible and convenient, as they are small, easy to set up, with no wires to inhibit mobility. The Locket Sync is a small, battery-powered generator that is accurate within 1 frame in 24 hours. The newest generation contains groundbreaking technology that wirelessly and continuously compares clock speeds between units and automatically makes adjustments if necessary. No drift whatsoever, so all files stay in sync with extremely long takes. To learn more about how to sync different devices, please watch our video tutorials where we explain timecode and sync workflows for common camera setups.